Hello everyone, and welcome back to Business Statistics. Today we're going to be covering Lesson 4, otherwise known as Discrete Probabilities. There are two types of problems that we'll see in this chapter. The first one is very similar to the one we're about to attempt, using the table with outcomes and probabilities. And the second one is using the binomial table. We'll get to that a little bit later. So without further ado, let's get started with this first example. The John Molson School of Business has provided the following probabilities based on past year's chances of winning an international case competition. So what we have here is a table with two things, okay? On the top, we have the number of competitions won, which is also known as the X's or the outcomes. And the second row is the P of X, which is the probabilities for each of these given outcomes. So now in question A, they ask, compute the mean and the standard deviation of the distribution. So let's start with the mean. The mean in this particular chapter can be written as E of X is equal to the sum of what? Each X multiplied by its given probability. Okay. Now, if you remember from before, what we had was the mean is equal to the sum of X divided by its given sample size. However, here, we don't have a sample size. What we do have, though, from here on out are probabilities. And because we have these probabilities, we can just as well compute the mean, okay? Let's see how we do this. If we add up all the probabilities of our second row, it gives us 1. And this will always be the case as long as we're taking into account all the probabilities, so all the outcomes of a given set, okay? Because think about it. If you take into account all the outcomes of a given set, then that makes up the population of that given set, and so the probability of the entire set should be 1, okay? Now, what else do we know? We know that within a given year, there are 5 different types of outcomes. You can either win no competitions, 1, 2, 3, or 4. And each of these outcomes has a probability assigned to them. So let's say, for example, right over here, winning 4 competitions within this given year only occurs 10% of the time. Winning 3 competitions within the same given year can occur 20% of the time. So, how do we obtain the mean? It's quite simple. If we know that all the outcomes within a given set make up the entire set, and each one has an assigned probability, then we also know that if we multiply each of these given outcomes by their appropriate probability, their corresponding probability, we'll obtain a certain number of competitions won. And then if we add all those different competitions, we'll obtain the average number of competitions for a given year. So let's illustrate it and you'll better understand. So this is going to equal, we know that 0 competitions won within this given year occurs 20% of the time. Plus, we know that winning 1 competition within this given year occurs 25% of the time. Plus, we know that winning 2 competitions within this given year occurs also 25% of the time. Plus, winning 3 competitions within this given year can occur 20% of the time. Plus, and finally, winning 4 competitions within this given year can occur 10% of the time. So let's do a quick recap. What this means is that within this given year, these are all the 5 outcomes and their corresponding probabilities, right? So within this given year, I can win 0 competitions 20% of the time. I could possibly win 1 competition 25% of the time, possibly 2, 25% of the time, possibly 3 with 20% of the time, and with a probability of 10%, I could possibly win 4. So what does this tell us? This tells me that within this given year, here I win none. Here I can win 0.25 competitions. Here I can win 0.5 competitions. Over here I can win 0.6 competitions. And finally, for my final outcome, I can win 0.4 competitions. Now when I add all this up, what do I get? I simply get my average number of competitions, which is a total of 1.75 whoops, sorry about that, 1.575 competitions that can be won on average per year. Right? So, once again, because we don't have a sample size, we have to use the probabilities that are given to us. And this tells us that of these 5 outcomes within this given year and their corresponding probabilities, I can win 1.75 competitions per year on average, because I can win 0.4 10% of the time, so that's 0.4 competitions. I can win 10% of the time, so that's 0.4 competitions. I can possibly win 3 20% of the time, so that's 0.6 competitions, and so on, adding them all up for a total of an average of 1.75 competitions, okay, according to the outcomes and their given probabilities. Now, the second part of the question is asking us to compute the standard deviation of the distribution. So, for this particular chapter, how would we write that out? The standard deviation, not the variance, be very careful, okay? So the one crucial difference is the square root. Please don't forget the square root. It'd be silly to lose points just because you forgot the square root. The square root of what now? Now, very similar to how we did the mean, this is going to be the sum of x minus, so each outcome minus the mean and this entire thing to the power of 2 multiplied by its given probability, and we're going to sum each of these up for the 5 outcomes, okay? So I'll just say that again. So we're going to take each outcome, subtract the mean, and then take that to the power of 2 to remove the negatives, multiply that by its given probability, and then all of these, so 5 in total for each outcome, 1 for each outcome, we're going to add them all up and then take the square root, and that's going to give us the standard deviation. Now, some of you, this might look familiar. That's because before, what we used to do was, and this is S for the sample standard deviation, we used to take the square root of what? The sum of the x's minus the x bars, which are the sample means, okay, to the power of 2, and we used to divide these by n minus 1, right? Look familiar? Here, however, once again, like I said, we don't have samples. What we have are our probabilities from here on out. So what we take is, once again, the outcome is minus the mean to the power of 2. That hasn't changed. But we're going to multiply them by the probability in order to determine that given outcome. What is the chance of that given outcome occurring to get our final number, right? So we saw earlier, if winning 4 competitions per year has a 10% chance of occurring, that's 0.4 competitions only. So to get my standard deviation, I'm going to do the same thing. I'm going to apply to the difference from the mean a given probability, so a corresponding probability, and then I'll determine what the likelihood of that outcome is, the number. And then all those added up will give me my standard deviation, okay? So let's go ahead and do it. We're going to do it the long way, just because it's the first time that we're doing it in this video. Maybe when we do a recap, we'll cut it a little shorter, but stick with me on this. If you want, you can just fast forward to the answer at the end, okay? So let's go right ahead and do it the long way. So we know that we're going to have our x minus mean column, and we're going to have another column where we're going to take that and do it to the power of 2. Okay. Now you all know we do it to the power of 2 to remove the negative sign, because if we didn't remove the negative sign, when we added them all up, we would get 0, right? The positives would cancel out by the negatives. And then we're going to take this number right here to the power of 2. And we're going to multiply each one by its corresponding probability, okay? And then at the end, we'll just add all 5 up. So let's go ahead and do that. So the first one, we know that the mean from our first part of the question was, let's rewrite it over here. It's equal to 1.75. Okay. So the first column right here is going to be each outcome minus the mean. So I'm going to have 0 minus 1.75, 1 minus 1.75, 2 minus 1.75, 3 minus 1.75, and finally 4 minus 1.75, right? And then we're going to take the number that we obtained for each one, and in the second column, we're going to do that to the power of 2, okay? So what I'm going to do to make this a little bit easier and not write too much here because it might get confusing, I'm just going to take the actual number that this gives me. So for example, in the first one, it would be minus 1.75, and then I'm simply going to do that to the power of 2, okay? I think that'll be a little bit easier. So this is going to be 0.75 to the power of 2. And we're going to have 0.25 to the power of 2. And then 1.25 power of 2, and finally 2.25 to the power of 2, right? So what I'm going to do in the final column is, once again, I'm just going to write out the number that it gives me. So let's say negative 1.75 to the power of 2. I'm going to write out the number that gives, and then I'm going to write out the probability on the side, okay? So this gives us 3.0625 multiplied by what? This would be the probability of my first outcome, which is my 0 right here. So I'm just going to take a different color like I did before. So because this is the 0, the probability over here has to be the one of the 0. So this is going to be times 0.2. Okay. So my next one is going to be 0.5625 multiplied by the probability of my 1 right here. So it's going to be the 0.25. Then I'm going to have 0.0625 multiplied by my third outcome's probability, so the 2, which is 0.25 up here. Okay, so 0.25, and then I'm going to have 1.5625 multiplied by 3 competitions 1 is outcome, which is 0.2. And finally, I'm going to have 2.25 to the power of 2, so 5.0625 multiplied by final outcomes probability, which is right here, which is 0.1. Okay? So because we're taking the long way, we might as well go all the way. So let's just do one final column where we have the product of the two, and then we'll simply add them up. So the first one is times 0.2, so we have here 0.06125. The second one, 0.5625 times 0.25. So here we have 0.140625. Then we have 0.015625. Then we have 0.3125. Then we have the last one here, 0.56025. Okay, so now we're going to add them all up, and I'm simply going to put them underneath the square root. So I'm going to put the sum under the square root. We don't need this anymore. So let's just put the sum down here under the square root. Okay. So 0.6125 plus 0.140625 plus 0.015625 plus 0.3125 plus 0.56025. This gives us a total of 1.6415. And then we simply have to take the square root of this to get the standard deviation because it isn't the variance, don't forget. And this gives us a total of 1.2812. 4 decimals is more than enough. This is perfect like this. Now, obviously, this may seem quite tedious at first, but I would suggest doing 1 or 2 this way just so you fully grasp how the formula works and understand it perfectly. And then feel free to take some shortcuts in the calculator if you're comfortable. Okay? So, I don't think I need to recap. This is, feel free to pause the video and just really absorb everything and take everything in one step at a time. All right? So let's move on to question B. All right, question B states, if JMSB receives $10,000 for each competition that it wins, what is the expected profit per year? Now, there are 2 ways to solve this question. The first one is, it's a bit of a longer way, especially since we already solved for the mean in part A. But what we could do is, we could simply substitute the number of competitions won by the expected profit, right? What I mean by that is, let's illustrate it. So instead of having the competitions won on top, we could have the profit received, right? So if we know that we receive $10,000 for each competition that we win, here we would have $0 because we didn't win any competitions. Here we would have 1 competition times the $10,000, so we would have a total of $10,000. Here we would have 2 competitions times the $10,000, so a total of $20,000. And so on, right? And then once we have the entire table figured out, all we have to do is recompute for the mean, but this time using the profit dollar amount instead of the number of competitions won, and we'll obtain the expected profit. However, because we know that the expected number of competitions won per year is 1.75, all we have to do is simply multiply that by the $10,000 and we'll get the expected profit per year. So this is a total of 17,500. All right? So I'll recap that just to make sure everyone understood. They want to know what is the expected profit per year. So what do we have already? From part A, if we want to take the shortcut, we know that the expected number of competitions won per year is 1.75. And we make $10,000 per competition. So if we multiply the amount we make per competition, the $10,000, times the amount of competitions we expect to win, we get the $17,000 and $17,500, which is our expected profit. for those that don't quite see that, that's okay. We can take the long route, which is simply, instead of computing for the amount of competitions won, if we know that we make $10,000 per competition that we win, what do? It's quite simple. We'll sub out the competitions won up here. So this first row of competitions won, we'll substitute it for the profit. So 0 competitions amount to $0. 1 competition is $10,000. 2 competitions, $20,000. 3, $30,000. 4, $40,000. And then we repeat step A for the mean, but this time instead of the mean number of competitions won, we'll simply multiply the dollar amount by its corresponding probability and obtain the expected profit. Let's move on to question C. Question C asks, what is the probability that JMSB will win exactly 2 competitions? So, remember what I told you before. The hardest part about probabilities is often translating a sentence into its mathematical form. So let's go ahead and do that first, and then we'll solve once we have the numerical version. What I mean by that is, the probability that JMSB will win exactly 2 competitions is what? So this is the probability that X, so that the outcome, the number of competitions you win, is exactly 2. Okay? So it's not at least 2, it's not greater or less or anything like that. We want it to be exactly 2. So that's equal to 2. So the probability of this is 0.25, which we have right here, okay, which is equal to 25%. It's the same thing. That's fine, okay? So before I move on to question D, let's go over some of the types of probabilities in discrete probabilities that they could ask you for. These will come in handy in binomial, okay? So when they say exactly, this is the equality, okay? This is one of the more obvious ones. Greater than, simply like this. Less than, simply like that. Now you could also have greater than or equal to. Now this one is like that. The difference here being, I'll spot it out for you guys. So the difference here being the additional equality, don't forget it. Now we could also have less than or equal to. Okay, so once again, don't forget the equality down there. Oh, sorry. We'll map it out a little better. There we go. And these are some of the more basic ones that we usually see, but as we see more, I'll make sure to point them out, okay? But just make sure that you distinguish between the ones that have the equality and the ones that don't. It's very important because let's say, for example, if I ask you for the probability that JMSB will win more than 2 competitions, so the probability that JMSB will win more than 2 competitions, okay? Okay, this does not include the equality. So what I asked you, was more than, not more than or equal to. And so when we plot it out in our table, it does not include the probability of 2, okay? It starts at 3. 2 is not included here. It's not more than or equal to 2, it's more than 2. So we have to skip the 2 in our table and start counting from the 3. Okay, so that's why it's very important to distinguish between these different signs. Okay, so let's go ahead and do question D. Question D asks, what is the probability that JMSB will win less than 3 competitions next year? Okay, so as we saw earlier, the less than is represented by this sign right here. So they want the probability that my outcome will be less than 3 competitions next year. Okay, so that does not include the 3. So here, let's do it this way. I think it'll be a bit more visible. So because I want less than 3, not including 3, it'll start from the 2 downward. Okay? So a different way to see this is, let me just rewrite my outcomes right here so I can show you. Okay? So these are my 5 outcomes, 0 to 4 competitions 1. Now, I am not including the 3. Okay? So one way to do this, a little trick I'd like to use for this chapter, because I want less than 3 and it does not include the 3, I'm going to start here from the 2 downward. Okay, so this way I know that everything inside this hook is included, and so it's from the 2 downward because 3 is not included. Okay, now another little thing before we solve it, very important, and this is going to help you when using the binomial table. The probability of x less than 3, because 3 is not included, you agree is the same thing as the probability of x less than or equals to 2. Okay? So very important to remember this. Okay? When 3 is not included, it's the same thing as writing the probability of x less than or equals to 2. Okay? So let's go ahead and solve for winning less than 3 competitions. So the probability of x being less than 3 is equal to the probability of x equals 0 plus the probability of x equal 1 plus the probability of x equal 2. So let's take a look. So this right here is this right here. This right here is this portion right here. And finally, this right here is this right here. Now you'll notice we took everything into account that is before the 3. Okay, so the probability of the 0, the 1, and the 2, and not the 3. Okay, so the probability of JMSB winning less than 3 competitions is the probability that they could win 1, that they could win 0, that they could win 2, but not 3 and not 4, right? So once again, it's the probability that JMSB could win 0 competitions, or 1, or 2, okay? Now, if you remember from the previous chapter, the OR is the union, so we're adding them up, and there's nothing to remove because there's no intersection, okay? These are mutually exclusive. So this gives us a total of 0.2 plus 0.25 plus 0.25, which is equal to 0.7. All right? So let's move on to question E. What is the probability that JMSB will win one competition only in 2 consecutive years? Okay, so there is 2 parts to this question. Okay, so let's chop it up. The first part is, what is the probability that they will win one competition? So let's start with that. Okay, so once again, let's translate that into the mathematical form. So we want to know the probability of winning only one competition. So we know that's 0.25. And then the second part of the question says, in 2 consecutive years. So that translates into what? In the mathematical form, it's the probability of winning one competition in the first year and winning one competition in the second year, right? And we know from our probability rules that the intersection, the and, is multiplication. So we'll take the probability of winning one competition in the first year, which is what we found in the first part, so 0.25, and multiply it by the probability of winning one competition in the second year, which is also 0.25, and this gives us a total of 0.0625. Okay, so I recap, 2-parter to this question. The probability of winning one competition, what is it? It's 0.25. We know that right here. And then the second part, what if we won one competition in 2 consecutive years? So only one competition in each year for the next 2 years. So that's the probability of winning one competition in year 1 and one competition in year 2. So 0.25, which we have right here, times 0.25, which we have same thing again, and that's 0.625. Okay, so let's go to question F. What is the probability that JMSB will win more than 2 competitions in 2 consecutive years? So once again, this is a 2-parter, so let's cut it up. The first part says, what is the probability that they will win more than 2 competitions? Okay, so we know that more than translates into this right here. Okay, so it's more than 2. It's not more than or equal to 2. So we don't take into account the 2. So this is the probability of winning more than 2 competitions, which is the same thing as the probability of x greater than or equal to 3, right? So remember my trick. We write all our outcomes down. Okay. The probability of it being greater than 2, so we don't take the 2 into account, is equal to what? This right here, which is the probability of it being greater or equal to 3. Okay, so we start taking into account from 3. So let's find that first part. So the probability of it being greater than 2 is equal to the probability of x equal 3 plus the probability of x equal 4. So this is equal to 0.2 plus 0.1, which is equal to 0.3. And then the second part of the question asks in 2 consecutive years, right? So part 2, what does this mean? This means the probability of winning more than 2 competitions in the first year and also winning more than 2 competitions in the second year, right? Now I know you all see this and you know what to do right away. So that's simply 0.3 times 0.3, which is equal to 0.09. Okay, so quick recap. More than does not include the equality, so it's greater than 2, which is equal to greater than or equal to 3. So we start counting from the 3. So that means that we'll include the probability of the 3 and the probability of winning 4 competitions, which is a total of 0.3. And we want that to be repeated in 2 consecutive years. So that's the second part of the question. So that means in year 1, you win more than 2 competitions, and in year 2 you also win more than 2. So that's winning more than 2 in year 1 and winning more than 2 in year 3, and the intersection, the rule is a multiplication, so that's a total of 0.09. Let's move on to the final part of the question G. So let's finish off with question G. Assuming that 6 years are randomly selected, what would be the probability that exactly 2 of them, JMSB has not won any competition? Now, there are different ways to solve this question. The easiest, I'm going to introduce very briefly binomial, just because it's definitely the quickest way to get around this question, okay? So when they say, assuming that 6 years are randomly selected, when you see those little words there, those key words, randomly selected, you should right away think binomial, okay? So right here, right away you should think binomial. A random selection within a given discrete probability. The best, absolute best way to solve this is binomial, okay? So very briefly, I'm going to introduce binomial because we're going to cover it in detail in question 2, okay? So let's just go ahead and see that real quick. Binomial, by definition, bi means there are only 2 outcomes, okay? And so there are only 2 probabilities, which are complement to one another. So the way binomial is structured is we'll have a P and a Q, okay? So P is the probability of what I'm looking for, so what the question is asking me, which in this case is I'm not sure. Yeah. So it's which in this case is no competitions 1. And so Q is the complement, which is simply 1 minus P, which is winning at least 1 competition. Okay. Now, if we do our little trick up here, so let's write out our outcomes, 1, 2, 3, 4. We can see that it all works out, okay? The probability that JMSB has not won any competition equates to the probability of winning exactly 0. So that's P right here. No competition's 1. And then the perfect complement, we're going the other way, is winning at least one competition, which is my Q. Okay, so we know we have it right so far. So what does the P translate into? The P translates into the P of X equals 0. Okay, so we need to assign a numerical value to P. So that's P of X equals 0, which we know from our table up top is equal to 0.2. Okay, so this right here, P of X equals 0, is this right here. Okay, and then our Q here at the bottom, I'm going to put it down here just because, actually, we'll start it off here, is the probability of X being greater or equal to 1. Okay, and that's equal to the probability of 0.25 plus 0.25 plus 0.2 plus 0.1, okay, which is going to equal a total of 0.8. Okay, so that's this right here, which is also this right here. Okay, so now I have both my P and my Q, so my binomial, my two outcomes, my two probabilities. So winning at least one competition and winning 0. And now I want to know, if we go back to the problem, they want to know what is the probability that out of 6 randomly selected years, exactly 2 have no competitions won. Okay? So, quick recap. First, we need to find our P in binomial. Then we need to find our Q. So I need to find what is the probability of what I'm looking for of my P, which is winning no competitions, because that's what they're asking me, right? The question asks, what is the probability that out of the 6 randomly selected years, exactly 2 have no competitions that were won, okay? So what I'm looking for is winning no competitions in a given number of years. So that's P, which is 0.2, and then Q, which is the complement, is winning at least one competition. Remember, this is binomial, so there's only 2 outcomes, and if there's only 2 outcomes in the whole set, the 2 have to equal 1, so 0.2 plus 0.8 is 1. So now that I have these 2, in the third step, out of my randomly selected 6, my sample size is 6, what is the probability that exactly 2 years out of the 6, I will have won no competitions, okay? So the first thing I'm going to do is write out the binomial formula. Now, don't worry if I'm going maybe a little bit faster here. We're going to see it in detail in question 2, I promise. So, the formula for binomial is P of a given x is equal to n factorial divided by x factorial n minus x factorial multiplied by p to the power of x multiplied by q to the power of n minus x. Okay, so before I go on to plugging in my numbers, a few things to point out, okay? It's very important not to get mixed up between the x right here for solving for the p value and the x down here when solving for the entire formula, okay? This x represents what they're asking you for in the question, whereas this x right here, I'm simply trying to determine the probability of the given outcome p, which is no competitions won, okay? So that's the first thing, very important. The second thing is, the reason why it's important to clearly identify P and Q and not simply plug whichever in either, is because the x in the question, what they're asking you for, is associated to the p. Okay? So when I'm going to plug 0.2 here, the exponent is the x of what we're looking for in the question. And so if I plug the 0.2 in the wrong place, if I assigned it to q, then my 0.2 is going to have as an exponent n minus x, and that's going to skew the whole formula. Okay, so it's very important to first determine what it is that you're looking for, which is your p, what its value is, and then from then you can determine the complement, which is the q, which is what you're not looking for. And then at the very end, you can solve for the x, so the number within the given outcomes that they're asking you to solve for. Okay? So we want, as a final step, the probability that within those 6 years, exactly 2, okay, so it's the equality, have no competitions won. Okay, so this is equal to, my n is my sample size, so that's my 6 factorial divided by the x in here. So inside the formula, the x is represented by what you're looking for in the question. Remember, I said that earlier. So the x here is this x right here. Okay, I'll do a little something. I think it'll be easier for everyone. So this x in the formula is the same as this x, this one, and this one. Okay, which is what you're looking for over here, which is this one. Okay, and that's what I meant earlier by not to be confused by the one up here when you're determining the probability of the outcomes. Okay, so this translates into 2 factorial down here multiplied by 6 minus 2, and this parentheses will be factorial as well, multiplied by, so then you see here is my p, 0.2, to which I associate what I'm looking for in the question, the 2 outcomes, exactly 2, and then my q, which is 0.8, is associated to the n minus x, so 6 minus 2, which is very different. Okay, and then we're gonna plug all this into our calculator, and then we're gonna solve, which gives us a final answer of 0.2456. Okay? So once again, very quickly, the P is what you're looking for, so what you're trying to solve for in the question, and here it's that exactly 2 out of the 6 years, JMSB has not won any competition, so we're looking for no competitions won as our P probability, okay, so as our question solving probability, so that's 0.2. Then Q is the complement, 1 minus P, which is winning at least one competition, okay, so if 0 is P, Q is the complement, so the complete opposite, so at least 1, which is 0.8. The way to know that you did it right is 0.8 plus 0.2. Binomial, there's only 2 outcomes in this set, should equal 1, so we're good. And then the final thing is we're solving for, out of the 6 years, we want exactly 2 to have no competitions won. So here is our formula for binomial, in which these x's all represent the same thing and are not to be mistaken with these x's up here. Okay, these were just to solve for the probabilities. And then we simply plug everything in, which is why it's very important to identify the Q and the P properly. Remember, the P is associated to what you're looking for in the question. And then we simply solve, plug in, be careful with the factorial in the calculator, and we obtain exactly 0.24576. Okay? Wonderful.